Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is yet another one about piecewise defined functions, and it is considered a review for those who are in college algebra or pre-calculus. This video is just going to be about finding equations for a piecewise defined function given the graph of the piecewise defined function. I'm not really doing anything that's too super technical here. I'm just going to take a look at a piecewise defined function defined in terms of linear functions. And I think that's just the easiest way to go about it. Also, generally speaking, that's what you're going to run into if somebody hands you a graph and expects you to find the equation of the piecewise defined function. So how do you do it? Well, let's see. The fact that there are three disjoint pieces here tells me this is a piecewise defined function. Also, what you're going to do is, because these are all linear, you're just going to find the slopes of each and points on each equation, and that will give you the slope-intercept form of the equation or the point-slope form of the equation, and then you can put that piece together. So for an example, this first one, and I'll do this in order of color here. So this first one I will call the red function. It goes through the point -1, -3. And it also goes through a point, and you kind of have to hunt for a crossing point, but this is actually a pretty good one here, -3, 2. Given 2 points, you can determine the slope of a line and the equation of the line. The slope is going to be the difference in the y values, so -3 minus 2, over the difference in their corresponding x values. That should be a -5 over, let's see, -1 plus 3 is 2. And note that that slope is negative and this linear function is decreasing, so that seems to work out. Now that we have the slope, we can use the point slope form. Y minus y1 is equal to m times x minus x1. So I'm going to go ahead and plug in, it doesn't really matter, one of these points. I'll just use that one right there. So the y value for that is 2. We know the slope is -5 over 2. And again, x minus the x value for this point. So that'd be x minus a -3 or x plus 3 when you do the mathematics there. And then distribute things through and isolate y. And that will be the equation of the first piece of the piecewise defined function. So I'll write that down below. So I'll call our function f of x. And again, the first piece is -5 halves x minus 11 halves. And that seems to be true for x being less than or equal to a -1. You can see for all these x values, they lead to y values on that first curve. So we're well on our way to finishing out this problem. Let's go ahead and concentrate now on the second curve. And actually that's kind of the easiest one because this is a horizontal line. The equation of the horizontal line is just the y value, so it's y equals -4. And you can see it takes on those values from x equals -1 all the way up to x equals +2, but including +2 because it's a solid dot there, but not including the -1. All right, so we're now 2/3 of the way there. Finally, we're going to talk about this last piece right here. And the way we're going to do this is essentially the same way we did the first piece, where we have these endpoints we consider, and when we consider those endpoints, we go ahead and build some type of linear equation based upon those endpoints. So let's go ahead and dive into that. This point right here is at x equals 2, y equals -5. The endpoint, actually, you actually don't need to go to the endpoint. In fact, there is a point right here that's pretty easy to work with. So you don't always have to go to the endpoint if you don't want to. The endpoint is a very nice point to consider though, so I'll just still use the endpoint in this case. The endpoint here is at 6, -3. The slope of the line containing those 2 points, remember, you have y2 minus y1 is divided by x2 minus x1. And I'm just pretending as though this point is the second point and this point is the first point. When you do the mathematics there, you get 2/4, which is the same thing as 1/2. So we know the slope of this line is 1/2. By the way, pretty easy to see. It rises 1 when it runs 2. So that's another way you could have done that. And now using a point slope form and using either of those 2 points as our x1, y1, it doesn't actually matter. I'll go ahead and use this point as our point x1, y1. We get the following, and solving for y, we get y is equal to 1/2 x minus 6. And that actually completes our entire piecewise defined function. Of course, there is a restriction on the domain here. The domain of this specific piece is all set of x values starting at but not including 2 and climbing all the way up to and including x equals 6. So let's go ahead and write that down. Now that we have that, that is the complete piecewise defined function. Now before we exit out of this video, I just want to mention one thing here that is kind of separate from this discussion, but still involved here. So one thing that you're going to note is when you're handed a graph like this, there are some assumptions you must make. For example, starting with the left edge of this function, notice that this line climbs and climbs and climbs, but they don't have a solid dot on the endpoint up above. This, therefore, you can assume means that the function just continues to rise forever. And that essentially means that the x values, you can plug in any x value that's negative as far as you want, right? I can actually plug in a -6 because it will land on the function way up above. So just be aware, if there's no solid dot on the endpoint and there's no open circle either, that means the function likely is going to continue on forever, even if they handed it to you like this. Now on the right edge, you can see we do have a solid dot right there, which means the function terminates exactly at whatever that x value is, which is 6. So the function does not climb past x equals 6. So just letting you know, that's a little bit of a intuitive piece that you have to develop when you're working with functions. And I just wanted to include that in this video. So with that, we are done with this, and I hope to see you in the next video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at ease. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry. Don't